In this video, we briefly introduce the low-in-band RCS circularly polarized microstrip antenna array, without using metasurfaces or changing the shape of the antenna. The independent regulation of the radiation and scattering performance is realized only through the feed network. The relevant work can be found in IEEE transactions on antennas and propagation. Circularly polarized antennas have been widely used in satellite communications and data link systems. However, simultaneously achieving a low radar cross-section and high radiation performance for a CP antenna is difficult. In the past few years, several methods have been proposed to reduce the RCS of CP, such as loading metasurfaces around or above the antenna and exciting low-scattering metasurface as a radiator. However, these methods will increase the profile and complexity of the antenna or deteriorate the aperture efficiency of antenna, compared with the conventional feed network of array antenna. CP antenna we propose is composed by two different across two antenna arrays, which load to different feed networks, named Feed Network A and Feed Network B. In our designing, the 3 dB branch line coupler is introduced. Because of the high isolation between the input and isolation ports of the 3 dB branch line coupler, the radiated energy does not pass through the feed network, and radiation and scattering energy will not affect with each other. The isolation port of the 3 dB branch line coupler was connected to another 3 dB branch line coupler located at the diagonal of the two crossed subarray through a microstrip line. Two 180 degrees phase shifting loads are introduced on the two connecting microstrip lines, forming the wideband feed network A. The feed network B is formed by rotating wideband feed network A around the subarray center by 90 degrees. The principle behind this is that each connecting line of feed network B introduces an additional 180 degrees phase shift relative to feed network A. Based on this design, subarray A and subarray B exhibit similar radiation characteristics and scatter a phase difference of 180 degrees under any linearly polarized incident wave. This enables scatter cancellation and thus reduces the overall RCS of the antenna. The proposed CP antenna array is fabricated and measured. The results show that it has broadband impedance and axial ratio characteristics. Compared with the reference antenna array, the in-band monostatic RCS was significantly reduced at 3 to 5.4 GHz under X and Y polarized incident waves, with a maximum reduction value of 19.2 and 20.18 dB, respectively. Because of its good CP radiation performance and low in-band RCS characteristics, the proposed antenna array is a good candidate for low observability platforms.